On to our first recorded session where we look through case studies and exam question solutions. This is an aid to help you understand the answers that you see in front of you, because we'd rather you understand than memorize. So let's take a first look at our first topic, which is the time value of money. And if we bring the screen up, let's bring this up full so you get a full view. Okay, so with our time value of money questions, we can ask you things to help you understand, or things that test your understanding of the concept. Well, our first question, define the time value of money. Essentially, it's the idea that the money you have in your hand today is worth more than the same amount sometime in the future. Okay, because there's more earning capacity and spending power in the money that you hold in your hand today. Okay, so that means that if you have a sum of money in the future and you want to know what it's worth today, you have to discount it back to present value terms. Okay, and if you want to know more about that, hang on and we will look through some of the questions to see what discounting is all about. Our second question. What is the formula for calculating the future value of a single sum? Well, when we look at money, we can move it along back and forth on a timeline. So if I have some money in my hands today, a sum of money, and I want to know what the value of it is in the future, I just apply the future value calculation. And you see the formula there, FV, or future value, equals present value, whatever the sum is we have today, multiplied by 1 plus whatever the rate of return is, raised to the power of, that little hat signal is raised to the power of n, the number of periods. Okay, so the rate of return is usually the interest rate we assign. So let's say you put your money in a bank and the bank is paying you 5% per annum and you leave it there for 5 years and it's compounded annually. Then R would be 5 and N, R would be 5% and N would also, be 5%. Okay? N would also be 5. So that's our formula for that. Our next question, what is the formula for calculating the present value of a single sum? And again, this is simply a reworking of that previous formula. So here, we've got a sum of money sometime in the future along a timeline, and we're trying to understand what its value is worth today. Now, when we do that, when we work out the present value of something, we find that we have to discount it. So this formula here, if I was to apply a verb to this formula, it would be the discounting formula. If I was to apply a verb to the future value formula, that would be the compounding formula. So going back to question 3, so if we find what is the present value of something, the present value equals the future value divided by 1 plus the interest rate raised to the power of the number of periods. Okay? It's very important that you understand whether your interest rate is quoted annually, monthly, whether your number of periods, whether that's in months or weeks or years. So always be aware of that. So they're two very simple questions. Now, it's unlikely that I'll ask you those in an exam, but I would like you to fully understand those formulas. They're very, very important to a lot of concepts that we look at in finance. Moving on to question 4. If you invest $1,000 today at an annual interest rate, I made it a bit too big. Let me just make it a bit big. Okay, if you invest $1,000 today at an annual interest rate of 5%, how much will it be worth after 5 years? Now, here we're asked to move $1,000 along that timeline 5 years into the future. And you're going to come across choices like this all the time in your private life and in your organizational life, where you're asked to deposit some money, you know what the interest rate is, and that refers to an annual interest rate, and you have to understand what it will be worth after a number of periods. Key thing to remember here is that you need to be able to do this on your calculator, and you'll need a scientific calculator to be able to do it. So essentially this question is asking me for a future value formula. Important, you have to understand whether the question asks you for a present value formula or a future value formula. This one is, say, I have £1,000 today, that's what I have in present value terms, and I want to know how much I will have after 5 years. So we plug it into the formula that we already have. So the future value equals the present value, which in this case is $1,000, multiplied by 1 plus 0.05. We change that 5% to its decimal companion, okay? And then we raise it, this little power, or this little hat sign, okay, if you do Control and 6 on a computer, or X with Y at the top on a calculator, that gives you to the power of, so it's to the power of 5. So 5% to the power of 5 years. So when we do that calculation, we'll find that we get 1276.28. So the investment is worth approximately $1,276 after 5 years. Now, what I want you to do is I want you to stop the recording and practice that now on your calculator. Okay, now we're moving on to question 5. What is the present value of receiving $5,000 in 10 years if the annual discount rate is 8%? So where are we looking at again? So imagine the cash flows on a timeline, and you have 5,000, you're going to receive it not in 2023, you're going to receive it in 2033. So what is that worth now in today's terms? Now the discount rate is the rate we apply, where that will take into account inflation, it takes into account what we would have lost on money invested in a risk-free rate, and of course what the uncertainty in receiving that payment. That's not something we really need to worry about now, where that 8% came from, but that is the figure we use in discounting. And everything is given to us in annual terms, so there's no need to change either or n in this instance. So what is the present value? So we can see straight away that we're being asked for a present value calculation. So present value equals 5,000 divided by 1 plus, or in this instance 8% is 0.08. For those of you not familiar with decimalization and percentages, when we move 8% to decimals, it appears as 0.08. And we raise that to the power of 10. Our present value is 2315. So you can see, okay, 5,000 in 10 years' time is not the same as 5,000 today. It's the same as 2,315 today, okay? So if you can understand both of those concepts, what you are able to do is you are able to move money along, back and forth, along a timeline. You're able to get present values and future values for sums of money, and that's a very important concept. If you are still struggling with that concept, stop the tape and go back to the start and go through those questions again. Now, our next question refers to this idea of an annuity. Now, if you remember from the classes, an annuity is simply a quick way of understanding the present value or future value of a series of cash flows. Okay? Well, you could be looking at saving for a car. You could be looking at pension payments. You could be looking at mortgage payments. You could be looking at trust funds. A lot of examples apply here. Bonds as well. You'll learn about bonds later on. So the defining features of annuities are that you can only do an annuity calculation if you have regular payments that appear at regular uniform intervals. Okay, so they're every year or every week or every day. It's got to be regular. You can't have it one week payment next week and then a payment 3 weeks from now. That won't work in an annuity calculation. They have to be at regular intervals. They have to be the same amount, okay? And key for annuities is there has to be an end date to the payments. The payments must be finite. You must know when the payments are going to stop, okay? So then and only then can you do an annuity calculation. So let's look at some of these calculations as a way of explaining ourselves further. Question 7. What is the formula for calculating the future value of an ordinary annuity? Again, this is not a question that you'll receive in an exam, but it's very important that you understand this formula. That's why I put it here in sample exam questions. I will give you a formula sheet in the exam. So here we've got FVA, which stands for future value of annuity, equals whatever the payment is. Let's say you're saving up for a car and you're deciding to save $500 a month. Well, C would be that $500. Okay? And the next part is then that you multiply that by 1 plus or raised to the power of n. Okay, again, we see that little hat symbol showing raised to the power of minus 1 divided by or. Okay, so what you're seeing there is, there should be a bracket after that, but that doesn't matter. What you're seeing there is that we are taking into consideration the annual rate and the number of years, okay, in order to be able to understand that future value of annuity formula, right? So our next question looks at the present value of annuity formula, and that is the two types of annuities that we can have, a future value annuity or a present value annuity. And so when you're being posed with a question, it's very important that you can tell the difference between whether you're asked for a future value annuity or a present value annuity. Whoops, let me go up here. Question 8. What is the formula for calculating the present value of an ordinary annuity? Ordinary annuity is what we deal with here. There are other types of annuities, one called an annuity due, which takes the payment at the beginning rather than the end, but that's not something we're going to concern ourselves with in this lecture series. So the present value of annuity formula is simply C multiplied by 1. C is your payment. Okay, so if I'm promised a stream of cash payments, what is that present value today? So whatever that payment is, multiplied by 1 minus 1 over 1 plus or the interest rate, okay, raised to the power of n divided by r. Okay, just as simple as that. You'll see that the two formula look quite similar, but there is a distinction between the two in terms of how the operations occur. Okay, so make a note of that difference. So we'll bring ourselves to our first question on annuities, and this is asking you for a future value annuity. So let's have a look at the question and see, can we distinguish this when it's a future value annuity question. A person plans to invest $200 every month for 15 years into an account that pays an annual interest rate of 6%. Okay, right, what will the future value of this investment be? Okay, so it's fairly easy to discern that that's a future value calculation. So, because it directly asks you for it. So this is a planning tool. So if I decide to invest my money, you will find that some of this will be relevant to you as you save for pensions. Okay, so this is sort of the same mechanism that's used by the people who take care of your pension. So, what's the first step that we need to take is we need to look at the fact that the payments happen every month. Okay, this is not an annual payment, but I'm given the time period as 15 years annually, and I'm given the interest rate as 6% annually, but the payments happen every month. Now, I can't just multiply 200 by 12 and then do the calculation. because it will give me a different answer to that which is correct. So what I need to do is I need to take into account the payments when they occur, because each of those payments gets a little bit more interest than the payment that follows it. Okay, so January will earn a little bit more interest from the payment that's made in February, which will earn a little bit more interest from the payment that's made in March, and so on. So it's very important that you drill down to the actual periods in which the payments are made. Okay, so the first thing we have to do is we convert to our annual rate to a monthly rate. And you'll be pleased to know that it's really quite simple to do. So we take our 6%, which we decimalize as 0.06, and we divide that by 12. Okay, and that will give us 0.005, which in percentage terms is 0.5%. So whatever money we invest, we'll earn 0.5% per month. Okay. The next thing we need to do is we need to convert the number of years to months. And so we have 15 years, and there are 12 months in a year, so 15 by 12 is 180. Now we have all the ingredients we need to calculate our future value annuity. Okay, so C in this instance is $200 multiplied by 1 plus 0.005 or 0.5%. raised to the power of 180, 180 being the number of payments there are in 15 years, minus 1 divided by 0.005. Okay, and our future value annuity is 23,770 cents. Okay, so what that means is that if you have a savings scheme that where you're putting money away for $200 every month for 15 years, that's the amount of money you'll have at the end of it. Okay, simple? Good. Okay, you can do this at the moment, interestingly enough. If you have a look at your bank and rates offered on different bonds and savings schemes, the rates in the region of 5% and upwards at the moment. So if you do have some spare cash lying around, it might be a good idea to start saving. It's a very, very good time for savers as interest rates tend to creep up. Now, moving on to question 9. A company wants to create a fund to replace a piece of equipment that costs $20,000 and has a useful life of 8 years. If the company can earn an annual interest rate of 4%, how much should they deposit in a fund each year to have enough to replace the equipment at the end of its useful life? Now, what's happening here? This is really a bit of strategizing on behalf of the financial manager in an organization. They know they're going to replace a piece of equipment at some stage. So they need to get the funds in place now in order to be able to do that. It's a very sensible piece of strategy. And you might see this happening in hospitals where different pieces of equipment have a useful life, but it's really, really difficult to do without them. So managers will be thinking about how they can make sure the funds are in place to make those big capital purchases when they arise. Okay, so here we are. So how much should they deposit in the fund each year to have enough to replace the equipment at the end of its useful life? So even though there's no word about future in this question, you can discern that it is about the future. How much are you going to have at the end of this savings scheme? Okay, because that's what it is. Okay, so let's calculate the annual deposit. Okay, using this future value annuity formula. So again, we've got to look at our C's and our R's and our N's to decide what they are before they're going in. So it costs 20,000 and it has a useful life. So 20,000 is the value that needed to replace the equipment. Oh, excuse me. This is actually looking for the payment, not for the end value. Okay, so it's looking for the payment, right? How much do we need? We have 20,000. that we need to have 20,000 at the end of 8 years. How much do we need to put away per year in order to be able to have that 20,000? That's what the question requires. Okay, so let's plug in the different values. Okay, so 20,000 is the FVA, future value annuity. Okay, that's what it's worth. Or is the annual interest rate. N is the number of years. Now, we don't have to make any changes to R and N here because we're told we just want to know how much we have to put away each year. Okay, so in this instance, what we need to do is we need to solve for C. Okay, and when you rearrange those calculations, okay, 20,000 equals C by 1 plus 0.04 raised to the power of 8 minus 1 over 0.04. If you rearrange that calculation, and it's quite a tricky concept or a tricky thing to demonstrate here. If you were using a financial calculator, you can just look for PMT, or if you're using Excel, you can look for PMT, and then that would find you $2,970.56. Okay, so this question, it's not something that I'll put in an exam, but I do want you to be aware that you can actually find those payments. To demonstrate the calculation here would sort of be too long and too cumbersome, but we do have the software around to be able to do that quite quickly these days. So know that you can have that payment, or know that you can calculate that payment if you need to. Question 10. Okay, question 10. Now we're looking at the present value annuity formula. Okay, so XYZ company is evaluating a project that will provide it with cash inflows of 10,000 per year for the next 5 years. Now that's a typical scenario. It could be any project where you envisage a cash flow. In other words, if it was a business, it would be your net income that goes back to over 5 years. Okay, so this the required rate of return is 10%. So that is what the company, or that was what you would expect for a company of this kind. That's 10%. So you can use your present value formula to find out the value of that project today. Okay, and when you find out the value for a project, you're then able to decide whether or not you should spend that money on the project. Okay, that's what we call a capital budgeting decision. It's something that we'll deal with in much more detail later on in topics 3 or 4. I can't remember which one. Okay, so our present value annuity formula. It's as we talked about it earlier. We have to establish first of all what C is, what R is, and what N is. And we see that it's 10,000 per year. The rate of return is 10%. We assume it's annual unless told otherwise. And we're told that it's 5 years. So everything stays in years. So this is an easier version. We don't need to change our R and N. So the present value is 10,000 by 1 minus 1 plus 0.10, 10%, raised to the power of 5 divided by 0.10. Okay, and when we solve that, we get $37,907. Okay, so you can work with that calculation and check that out. Now that's all we have on annuities, future value annuities and present value annuities. If you understand what they are, then you're in good shape for any kind of question that will come up in the exam. I won't ask you to work out payment question in the exam. I wanted you to know that it's there. Similarly, in our examples, there is an implied rate. You can figure out what an implied rate is in a regular future value calculation, and that's not something that we'll concern ourselves with here. Okay. So the second topic that we're going to look at is the one relating to risk and return. So here we have some sample exam questions on this. Okay. So in financial investing, the concepts of risk and return are crucially and deeply interconnected. Please provide a detailed explanation of the following. Okay. Define the concept of risk. Define the concept of return. Talk about how they are linked in investment decisions, and you can illustrate your relationship with an example. Okay, so this is a quite a detailed question that requires your writing skills, I'm afraid. Now, I never judge the quality of English in an exam question. Okay, I'd simply look at the quality of the idea, your understanding of the concept. English is a different class. I'm not interested. Okay, as long as I can understand what you're trying to write, then it's perfect for me. So that's the one thing that I want you to note about when you're writing down any kind of answers. Okay, so risk essentially refers to this potential either to gain quite a lot or to lose quite a lot. Okay, it's the fact that your actual return on an investment will be different from the return that you expect. Now, the degree to which it varies away from that expected return is equivalent to the magnitude of risk. In other words, the riskier something is, the further away the possibilities of getting a return are from that expected return. Okay. So in other words, if I have an expected return, usually which I take as an average return from investments in the past of 10%, and I have a risk value of 20%, well, there's a possibility. For the most part, I could I could lose 10% or I could gain 30%. Okay, so it's a concept that allows you to understand the dangers and opportunities around a particular investment. It's very important that you look at return alongside of risk. Okay, and it's important as well that you understand what we call the risk-return trade-off theory. In other words, the higher return you're going to get, you can expect more risk to accompany that. Okay, so that's basically what you'll read in front of you here. So to have a quick read of that, go back over our class notes or the class notes that you've made, or go back over the book to get a full understanding of that concept of risk. So let's have a look at the question. Sultan is considering an investment in a new startup company. He has made the following estimates based on his analysis. There is a 20% chance the startup will be very successful, in which case he will get 50% return. Okay? There's a 50% chance the startup will perform moderately well, and he'll get a 20% return. But there's a 30% chance that the startup will not be successful, yielding a return of, or a loss of, 30%. Remember, return can be negative as well as positive. Calculate the expected return on, that should say Sultan, not John, on Sultan's investment. Okay? So the expected return on an investment given a number of possible calculations. Okay? Each one has a probability. So we are 50% chance, that's a probability value that we'll get a return of 20%. Our 20% chance, a probability value will get a return of 50%. And our 30% chance will lose 30%. Okay, so we have our probability values. Now, some of you might ask me, where do we go and get these probability values from? That is a calculation that can be made only by the person on the ground with an understanding of the market and an understanding of what is likely to happen. Okay, for our purposes, we'd simply just take those probability values and run with them. Okay, rather than try and understand where they are. Sometimes, instead of using probability values, we will have learned this, you can look at historical returns of either that investment or similar investments as a way of coming up with a risk number. Okay, so, but both will allow us to anticipate what an expected return is. If we were looking with probability values, what we need to do is we need to multiply the probability value by the potential return, add that to the next probability value multiplied by its potential return, add that to the next, let's call it scenario, multiplied by its potential return. Okay, so if you do that question, you'll see that 0.10 0.10 minus 0.9 is our expected return. Okay, the expected return on, should be something. Okay, I use these examples in another country. So the expected return on John's investment is 11%. Okay, so that's our expected return. If you were using historical returns, you just simply use the average return. You take an average return. Okay, but now we have a probability value, so we assign that probability value. Let's move on to the next question. Consider an investment that has the following possible outcomes: a 30% chance of a 15% return, 40% chance of a 10% return, and a 30% chance of a 5% return. We have probability values and we have three different scenarios. Calculate the standard deviation of the returns on this investment. So from the class, you will have learned that the risk measure that we use for investments is standard deviation. We place this alongside returns. Standard deviations are given to us in the same units as the expected values that we look for. So in other words, returns are given to us in percentage terms, therefore standard deviation is given to us in percentage terms. So let's calculate, first of all, the return on this investment. So the expected return on this investment, or otherwise what on average we could expect, is, again, we do those probability values by the returns, adding them together for the three scenarios, and we get an expected return of 10%. Now we have to calculate variance. Okay, so variance in this instance, you'll remember from the slides, is this operator here is called a summator. Okay, so the sum of the probability of each scenario A being scenario A, scenario B, scenario C, so the probability of each scenario multiplied by the return on that scenario minus the expected return overall raised to the power of 2. Okay, so effectively what you've done here is you add for each scenario, you perform this calculation, and at the end you add the three scenarios together. So our first one, there's a 30% probability that we're going to get 15%. We minus out our average or expected return, which is 10%, raise that to the power of 2. The second scenario, 40% probability that we're going to get 10%. We minus out our expected return, raise it to the power of 2. And the 30% probability that we're going to get 5%, minus our 10% out, raise it to the power of 2. So we have our three values here. And when we calculate them down, we will discover it's 0.00075 plus 0 plus, again, 0.00075, which gives us 0.001.15. Okay, the next thing we do, in order to find the standard deviation, because variance is a number we can't really do an awful lot with, so in order to find the standard deviation, we will get the square root of the variance. So the square root of the variance, again, it's on your calculators, there's a square root function. You take the square root of our previous number and you'll see that's 0.0387 or 3.87%. So now my investment has an expected return of 10% and a standard deviation of 3.87%. So 99% of the time, I know my investment will be within 3 standard deviations of the mean. Therefore, I know with 99% confidence that my investment will be either it'll be somewhere between minus 1% and 21%. Okay, because all I do is I multiply the 3.87 by 3, and I take from backwards or I go forwards. Okay. Okay. Now we can continue. Sorry, I didn't know how to pause this. This is the first time I've recorded on QuickTime, so The pause button escapes me. So let's look at the next question. Consider an asset that has the following annual returns over the past 5 years. So here, what we're doing is we're looking at the other way of assessing returns and the other way of assessing risk by using the historical values. So we dispense with the idea of calculating probabilities. We're looking at what is likely to happen based on what happened in the past. So we've got year 1 to year 5 here, and you can see this ranges from 12% to 10% in terms of these are the returns that experienced over the past 5 years. Now the question asks you to calculate the standard deviations of the return on this asset using this historical data, 12% being last year, 9% being 2 years ago, 15% being 3 years ago, and so on. Okay, so the first thing we have to do is we have to calculate our expected return, which is simply the average return. So if we add all these together, okay, and divide by the number of years, we'll find that our expected return is 11.4%. Okay, so on average, we can expect to have 11.4%. That's what you tell investors or whoever it was you were trying to communicate this piece of information to. But they won't be happy with that. They will want a risk calculation alongside it. So now let's calculate the variance. So with our variance calculation, if you go back to your slides, you'll see that we first calculate variance, then we calculate standard deviation. So standard deviation is expressed in the units of whatever it is we're looking at. So we're looking at percentage returns. So standard deviation will express risk in percentage returns. Variance is the first part of the operation to find standard deviation, essentially. It gives us a number that doesn't really make much sense. That's why we put it into standard deviation. But variance essentially is we take our each scenario's return, we take away the expected return and we square that, okay? And it's the sum of all these operations, okay? So it's the sum of squared deviations from the mean, okay, divided by the number of years, okay? And so we get a figure here which is 0.000424. Now that number doesn't really make any sense to us. So what we need to do is we need to find the square root of that variance. So by just putting it through a square root function, we can see that it is 2.06%. So we have an expected return with a risk value of 2.06%. Now that's a relatively small risk value, okay, because if you were to plot that on a normal distribution, 3 standard deviations away, or 3 standard deviations below the expected return would simply be 6.18% below. So there's a good chance rather than earning 11%, you'll earn somewhere in the region of 4%. There's a good chance, but there's also an equally good chance that you could earn somewhere in the region of 17%. Okay, so that's the way to think about it. Now you can imagine if that risk value, that standard deviation value is higher, then the possibilities that you could lose or gain are greater on either side. Now we're looking at question 5 now. So consider an investment with the following annual returns over the past 5 years. Again, we have our returns under each of the years. And now we're asked to calculate the coefficient of variation for this investment. Now, so what this does, it allows us to compare with other investments, okay, bringing into consideration the risk. So we can look at investments and try and understand which one is the better one to use, okay? So our first what we do is we calculate the average return, okay? Again, add up all the returns, divide by 5, and that'll give us our expected or average return is 11%. The second thing we do is calculate the variance, and so variance, remember, is the sum of squared deviations from the mean. So each each year is, the first year was 8% minus 11%, that's our expected return raised to the power of 2. Then we add this to the second year, which was 12% minus 11% raised to the power of 2, and so on, divide by 5 at the end. And we can see our variance figures 0.004, which we don't really know how to conceptualize that. So again, we'll stick that into a standard deviation formula. Okay, and we see that our standard deviation is 2%. So in order to be able to understand the coefficient of variation, effectively we take our 2% and we divide it by the mean. And in this instance, we get 18 or 0.1818, which is 18.18%. Okay? So effectively, we can go along and look at another investment and compare it and say, are we getting, what's our risk relative to our units of return? Is this better or is this worse? So it allows us to compare across time. So that's all I have for you with regards to this particular topic in possible exam questions. But again, look, as long as you understand what we're doing here, you should be ready for any exam question that comes along.